have this, right? So visualize this triangle, the plane of your triangle, and then two on the axes, right? Like kind of right here and then right here, okay? So you have this is your triangle, your plane of your triangle. So what's the bond angle between this CL/CL?
120.
120, right? So we have 120 available. Okay, what about between this? 90.
Wait, if they have a flat plane and an axis.
Okay, and then what about between this? 180. So here you have, for trigon bipyramidal, you have three bond angles available. 90, 120, and 180, okay? Alright, now let's go into octahedral, okay, SF6. So sulfur, how many valence electrons? 6.
Yeah.
And then fluorine has, how many does fluorine need?
1.
Remember how we said fluorine was super reactive, and it really, like chlorine, it really wants to grab electrons? That's what's going to happen here. It's going to access all the sulfur's electrons.
Right, so it has, you have something that looks like this, okay? So, FF, and instead of a triangular plane, you have a square plane. Okay, so you get a square plane, right? And then earlier on over here, how we had the two CLs at the top and bottom, here we saw them on the top and bottom, we have a square plane instead of a triangle plane, okay? So does someone want to guess what kind of bond angles we see?
90 degrees.
90 degrees.
I heard it from that side.
45? No. Not where. First of all, I mean that's a good guess, but where would you see 45? Yeah, it's okay. 180. But between the two axial ones, right? So 180. What else?
Are there any more?
No.
I have a rhetorical question.
Oh, sorry.
Awesome.
I thought you were questioning it. Like, no, it's a rhetorical question. But thanks for ruining Jack. But I guess we ruined our own rhetorical questions. All right. Well. Anyway.
It kind of forms like.
Why do you think it's called octahedral if there are only 6 shared pairs?
I'm wondering that too.
I had an answer for it. Hold on, let me think about it.
Yeah, it
Yeah.
forms 8 triangular surfaces.
Yeah.
So between the 4
Like,
around and the top is 4 faces, and between the 4 and the bottom and the top is 4 faces.
Okay, does that kind of make sense? I didn't show that well, but you have 8 triangular surfaces that are formed. Thanks, Rick. That's why you're here. Okay. Well, anyway, so
Is
these
that kind of point?
what? Yeah. These are shared domains. Okay. Here we have make a note that the shapes we discussed have no unshared domains, right? What kind of geometry are we talking about right here? Molecular geometry. Molecular geometry, okay? That's important. All right.
Why is it molecular geometry?
Yeah, why is it molecular geometry?
You have to talk.
Hmm?
This is the geometry of how the molecules form.
We're talking about how, that's literally the answer, guys. Molecules
We're
are
not
bond.
trying to trick you.
Okay, does everyone have this down? You guys good? Can I erase it? You want to take a picture of it?
Like, take a picture.
Yeah, that's good.
Can you just keep writing to the right?
Yeah, all right. Well, so we discussed how it would be if we had a shared pair, right? So now we're just going to kind of logic out what it would be if we had an unshared pair, okay? So let's go back to our 4 electron domains, right? So I'm going to do X has A, and A. Okay, similar to, this is going to be our